Okay, let us discuss the next problem. So this is something related to center of mass. So this problem is really a quite interesting problem. So try to understand this problem. So two particles of equal mass m. So let us first write down the sentences. So two particles of equal mass m are connected to a spring. Two particles of equal mass m are connected to a spring and rest on a frictionless horizontal table. Rest on a frictionless horizontal table. If an external force F is applied, to one of the if an external force F is applied to one of them, describe the motion of the system. Describe the motion of the system. Describe the motion of the system. Let us say this force is basically vector force. So F vector you can put here. So we are applying a force F, and then we have to predict the motion of the center of mass, and you have to discuss the motion of the system. So let me show you the diagram. So you have two objects. So I have an object here and I have an object here. These two objects are masses m. So just make a rough sketch of this. So this object and this object, mass m and mass m, these are kept on a horizontal table. So this table is a horizontal table and horizontal. And friction of this table is 0. So this is a horizontal table. Friction is equals to 0. That is mu is equals to 0 given to you. Are you getting? Now what we are doing is we are applying a force vector F. So we know there is a force that is applied on this block, mass m block. And now the question is saying describe the motion. So we will go slow. So let us copy this one. Now if you see, I can make another diagram of the same thing. Now let us say this is my system. So this m and m. So this constitutes my system. So this is whole is my system. Now external force is F. So there is a vector F that is acting as external force on this one. Are you getting? So this is mass m, this is mass m. So my system consists both masses as well as the spring. A spring and this mass constitutes my system. So this is my system. There is no friction force because this is kept on a horizontal table. Now I am applying a horizontal force F. So this is a force. This can be in any direction in the plane. So this is in the table of the plane. But it can be any angle to this spring. Basically, that's why I am giving you vector F. So there is no need to specify the angle because if I give you the vector F, this means I am giving you the direction also. So direction of force is known to you. Now we have to find, so now my system is this. If I see my system, so what is the total force acting? So to describe the center of mass, I can say total force is equals to mass into acceleration. So total force that is acting is F and mass of the system is 2m. So what is the system acceleration? So what is the acceleration of center of mass? So write down. So what is the acceleration of center of mass? You write down. Okay, good. So this is F by 2m. So you see, so let me go for the next page. I think all of you have copied. So you just copy this one if you have not copied. You're getting? So let us go for the next. So you see, I can say center of mass, acceleration of the center of mass will be Fy total mass of the system. Mass of the total system mass is m plus m. So that is capital F by 2m. So acceleration of center of mass. This is neither acceleration of one block, neither acceleration of another block. This is a total acceleration of center of mass. So total acceleration of center of mass is given by F vector by 2m. Are you getting? Now if I want to analyze the motion of a single block, it will be slightly complicated. So you see, if I see this block, now this block, if my system, now there is a force that is acting in this direction because the spring is basically elongated. If the spring is elongated, on this block there is a force in this direction that I have not shown. So if you see this block, there is a force in this direction, but if you see this block, there is a force in this direction, F1. I does not know the spring constant, so in the problem a spring constant is not given. So I cannot calculate F1. Basically the motion of this block is slightly complicated. We cannot simply say that the acceleration of center of mass is so F by 2m. It's very difficult to find the acceleration of this mass because force is also a function of x. If you change the x, this force will change. So the motion of this mass is complicated, but the motion of center of mass is very simple. You see here. So let us copy this figure and then we will go for the next. Copied. So just copy. So I am saying on this block there is a force F1 that is acting in this direction because the spring is elongated. On this block the force is in this direction, the mass is m. Now the writing the equation of motion for this block is not so easy because force is a function of x and a spring constant is not given in the problem. Even if it's given, it's difficult because this kx, x I don't know. So writing the motion equation of motion for this block is slightly complex. So, but you see, so description of motion of center of mass is very simple. So I know the center of mass. Acceleration of center of mass is nothing but so simple. Acceleration of center of mass is F by 2m. And now if I do integration, I can find acceleration as well as velocity. So if I know acceleration, I can find velocity. Are you getting? So if I know the acceleration, I can integrate one time and I can get velocity. So what is the point is? Point is description of motion of center of mass is simple, but the description of each block is not so simple. So let us copy this one. Okay, let us make situation slightly complicated. Now we have two blocks, block A and block B, same kind of question, but now they are moving in one line. So this is a one-dimensional problem. So this block can move only in one direction. These two blocks are basically compressed, so basically connected by a spring. So this spring is connecting these two blocks. Let us say mass of one block is m1 and mass of another block is m2. So let us say this is m1, this is m2. So let us call this block has mass m2 and this block has a mass m1. So this block is m1 and this block has a mass m2. Now I am calling the one is, so this is my m1, this is my m2. And I am calling this block as block A and this block as block B. Now let us say if these two blocks rest on a frictionless table and coupled through a spring, now what will happen? What is the motion? If we slightly compress these two blocks and release with no net force. So let us say what is happening. So let us read the language first. Consider the two block A and B. No need to write, just simply understand. Consider the two block A and B of mass is m1 and m2 coupled by a spring and resting on a horizontal frictionless table. So once again, this is kept on a frictionless table and this is a horizontal table as shown in the figure. So this is the figure. So this is a frictionless table So this is mu is equals to 0. So this is kept on a frictionless table. Now the next part of the question says, if I compress these two blocks, so basically it will go compression. So you will have initially this. After some time, if I compress these two blocks, so M1 will be here and M2 will be here. And now after compression, I leave this one. So I compress this one this side. So it's very simple. So what we are doing, I am compressing these two. So these two blocks are compressed and then I leave these two blocks. So these two blocks basically, are you getting or not? So these two blocks gets compressed and you have somewhere here and then I leave these two forces. So these are the two forces that is acting. This is on this block, this is on this block. After the compression, I keep this force for some time and then I leave these two forces. What will happen to the motion? That is my whole goal. So I am asking what will happen to the motion. So I will give you a hint. What is the hint is, when I just remove the forces, at that point of time I can say there is no external force acting on the system. My M1, M2 and the spring contains my system. So what is my system? M1, M2 and a spring is my system. And just I remove the force, at that point of time I say there is no force acting. Just remove by the force. That point there is no force acting. And what is the velocity at that point? Everything is at rest. The blocks are rest, the spring is rest. So when I just remove the force, everything was at rest. That is velocity of the system of 0. Velocity of masses are 0. So I can say when I just remove the force, what is the total momentum? The total momentum was 0. Are you getting or not? So now you apply this thing and tell me what will be the acceleration of center of mass at any time. So what is my task? Your task is you have to tell me what will be the acceleration of center of mass at any time t. So what will be this value? What will be the acceleration of center of mass at any time t? What will be the value? And when I remove the force, I call that time t is equals to 0. So what is t is equals to 0? Time when I just remove the force. So this time removing of force. So this is the time when I removing the force. So F external is just remove, that is F external is 0. After that always we have external is 0 because this system is connected through the spring. The friction force is 0. So when you t is equals to 0, for all t is greater than equals to 0, also force external is 0. Did you agree with me or not? After t is equals to greater than 0, forces are also 0. So if you want to, you give me the VCM and ACM. I will give you a hint. You have to do something related to momentum conservation. Those who have not copied, let us copy fast. And then we will go for the next page. Are you getting? Okay, let us go for the solution. So you see, we release the system. So let us copy this one. We release the system of given two blocks from the rest. Let us copy. We release the system of the given two block from the rest. Net external force on the system net external force on the system is 0. Next external force on the system is 0. So what we are calling is, so when you just removing the force, so net external force was what? 0. So F external, that is net, we have already said this one, 0. If you are just removing, there is no external forces. What is the system? Your system contains this mass, a spring, and this mass. So this is mass A, this is mass B, we are also calling 1 and 2. So these masses are, so if you remove the external force, there is no external force because no friction. Okay, you can say weight are the forces, but this is not acting in the horizontal direction, weight is acting in the vertical direction, normal reaction is acting in the vertical direction. I am talking something about in the vertical direction. This force and this force are balanced forces. There is no motion in the vertical direction, so normal reaction is always balanced by mg. You see, normal reaction is balanced by mg. This here you will have n1 mg, and here you have n2, and you will have m2g. So n1 is balanced by m1g, and similarly n2 is balanced by m2g. So there is no point of talking about in the vertical direction. The question is in the horizontal direction. Now there is no force acting in the horizontal direction, that is F external is 0. So I can also write, if the F external is 0, this means momentum remains conserved. Are you getting or not? So initial momentum of the system, that is the m system, m into v into vcm, should be same mass of the system and vcm at any time t. Are you getting or not? So this is at t is equals to 0, and this is at t is equals to t. But I know at t is equals to 0, what is the VCM? That is 0. Everything was at rest. So what will be the t VCM at any time t? Again, this will be VCM will be 0. So VCM will be 0 for all time. So this is a vector. So this is a VCM will be 0 for all time. So for all t. Now I know very good result. VCM will be 0 for all time t. Are you getting? Now what about ACM? You see, what is the ACM? Acceleration of center of mass is force external divided by mass of the system. Are you getting? So mass of the system is basically 2m or m1 plus m2. What is the force external? 0. So what is the acceleration of center of mass? 0. So center of mass always have a 0 acceleration. Now acceleration of center of mass is 0. So what is the velocity? Velocity of center of mass at any time t is also we have derived. This is 0. Are you getting or not? So we have derived velocity of center of mass is 0 for all time because there is no external forces is acting. Acceleration of center of mass, that is also 0. Are you getting or not? If you do this result, you find acceleration of center of mass is 0. This means I can say if something differentiation, velocity differentiation gives acceleration, so I can say velocity is constant. But I know velocity at t is equals to 0. So at all time, what will be the velocity? Velocity of center of mass will be 0 at every time. Are you getting or not? Because I am saying either you can get this result from here itself, because if you apply the momentum conservation, initial momentum was 0, so velocity of center of mass has to be 0, or you can get the same result if we apply acceleration of center of mass force by mass, that is 0, so velocity has to be constant. Initially at t is equals to 0, velocity of center of mass was 0, so that these are basically vectors. If you want, you can write vectors. So the velocity of center of mass will be 0. Now, so this means center of mass of the system is always in rest. So you can write center of mass, the same thing I have written this side. So this is only the printed thing. If you want, you can write, otherwise we have done the same thing right side. There is no need to write. So you can forget about all these things. We have done the same thing this side. You see, momentum at any time t is given by mass into velocity of center of mass into t. At t is equals to 0, basically this was 0. So velocity of center of mass will be 0 for any time t. So you can write the center of mass of system is always in the rest. The center of mass of the system is always in the rest. The center of mass of the system is always in the rest. Are you getting? The center of mass of the system is always in the rest. Okay, so let us discuss the next part in the same problem. If I say you to prove one thing, so let us say, if I say you, okay, let us take the, let me take the next page, different page. Okay, can I take this one? Okay, good. So let us say, if I have something like this, I need to have, okay. So now the same problem we are discussing, you have center of mass is in the rest. So this mass is moving, this is m1, this is m2. Can you tell me what is the position of mass m1 and position of mass m2 at any time t? So basically momentum, total momentum any time has to be 0. So I can say from center, let us say this is my center of mass at any time t. Because center of mass has to be rest. It is not moving initially. It will not move. So velocity of, we have already proved, velocity of center of mass is 0. Acceleration of center of mass is 0. At all time velocity is 0. This means center of mass will always remain here. Are you getting it? So what is happening? This block is going these two blocks are basically moving up and down. So they maybe do simple harmonic motion. So this can go this side. This can go keep on. So this will go this side. Again come back. This will go this. Okay, so let us discuss. So basically these two blocks will add to SHM. Are you getting or not? So one can find the time period for this also. Sometime we will discuss the time period for this block. So this block will go. So this whole system will move around the SHM. So this will do SHM and center of mass will remain. So in this system, what is the point that is always in rest? So this point, the center of mass. This is a point that always remains in the rest. So in this case, I can say center of mass always is in the rest. So center of mass is basically always in the rest. Are you getting? Now if we want to find what is the coordinate of this mass, what is the coordinate of this mass with respect to the center of mass, so what we can do? So let me take something like this. So this is my plane. So this is mass m1, this is mass m2. Now let us say this is my center of mass. So what is the distance from this block x1? Let us call this distance is x2. So I can apply, so mass m1, mass m2, I can shift my origin here. So let us say this is my origin. So center of mass is in origin, that is x is equals to 0. So center of mass I can write m1, so this is my negative side. So m1 minus x1 plus m2 x2 has to be equals to 0 divided by m1 plus m2. So if I solve this one, I will get m1 x1 is equals to m2 x2. So this is a relationship between these two masses. You can write x1 by x2 is equals to m2 by m1. Now this is the important result. If you see, if m2 is greater than m1, let us take one case. If m2 by m1 is greater than 1, that is basically m2 is greater than m1. If I have something like this, m2 is a bigger, heavier mass and m1 is a lighter mass. So m2 by m1 is greater than 1. So this means x1 by x2 is greater than 1. Are you getting or not? So x1 by x2 is greater than 1. If this is the case, I can say x1 is greater than x2. Are you getting? If x1 is greater than x2, this means what? If x1 is greater than x2, this means, let us try to visualize, have a physical meaning. So this is x1. So that is x1 is corresponding to a smaller mass. m1 is a smaller mass. So a smaller mass will have, it will go more away from the origin. Are you getting or not? So if the smaller mass, so this is my center of mass. So if this is my center of mass, a smaller mass, so let us say I have a smaller mass this side. So this will go away, more away from the origin. So this is x1, this is x1, that is more distance, and this will be x2, that is the physical meaning. The lighter mass will go more away, and the heavier mass, that is here, Are you getting or not? So this is the meaning of. You can also tell in terms of velocity. I can also write, if I differentiate, x1 will become v1 and x2 will become v2. x1 by v2 will be m2 by m1. Are you getting? So now again, if you have m2 by m1 is greater, so then this means v1 will be greater than v2. This means a smaller mass will have higher velocity than the bigger mass. The mass that has a the block that has a higher mass will have lower velocity. So the block. So let us write we can write the block with larger mass will have lower velocity. You keep writing the block with larger mass will have lower velocity, will have low velocity. So the block with higher mass will have low velocity. Let us write the block with larger mass will have low velocity. Are you getting? So this is a quite interesting problem. I will give you one task. Can you tell me what about the kinetic energy which will have, so let us say one situation when m2, so the same situation, m2 is greater than m1. What do you say about kinetic energy k2 and k1? Which will be greater than? Either k2 will be greater or k1 will be greater. So derive this thing and let me wait for some time. So you write half m v1 square, half m v2 square, and you can derive this result. Which will have higher kinetic energy. So let us write half m v1 square v2 square and then put v1 is equals to v1 by v2 is equals to m2 by m1. You will get the result. Okay, so let me solve for you. So let us say kinetic energy 1, that is a half m 1 v1 square. Kinetic energy 2 is equals to half m2 v2 square. k1 by k2 will be m1 by m2 v1 by v2 whole square. Are you getting? Now if this is the case, m1 by m2, and we have already solved, b1 by v2 is what? b1 by v2, you see here, b1 by v2 is nothing but m2 by m1. So I can put it here. b1 by v2 is nothing but m2 by m1. So this is m2 by m1 whole square. So this is simply m2 by m1. And now in my situation, we have been given to you, that is this situation m2 is greater than, oh my god, this is m2 is greater than m1. So this is m2 is greater than m1. Are you getting? So we have been given you m2 is greater than m1. This means m2 by m1 is greater than 1. Are you getting? This means k1 by k2 is greater than 1. So 1 will have higher kinetic energy. So k1 is greater than k2. So this is the situation for the kinetic energy. K1 will have a higher kinetic energy than K2. Now things are very simple in this case. Now let us write this problem and we will just go for the next problem that is very interesting. What will happen if there is external force that initially if I applied? I will discuss that also. So in this problem what we have learned, you have two blocks. These two blocks are basically connected by a spring. If you apply a force or if you compress somehow this spring and leave this one, then I can say at t is equals to 0 there was no external force that is acting on the system. My system contains two masses and a spring. Since at t equals to 0 there was no force and even there was no velocity also, so at t equals to 0 there was zero momentum. And in the system, during the motion there is no external force acting. This means total momentum of the system has to be 0 for all time. So this suggests me velocity of center of mass will be 0 for all time because it was 0 initially. And I have to remain the momentum conserved. mass is always conserved, this means I have to keep the velocity also conserved, because mass m1 plus m2 that remains in the system. Mass is neither lost, neither mass is gained. So I can say I have to have velocity that is 0. Center of mass velocity will remain always 0. From there, I can also calculate acceleration of center of mass, that is F by m, because there is no force acting. So this means the acceleration of center of mass will be 0. Now from there I can find out the velocity of center of mass is always 0. Initially it was 0 and it is always 0. So I said velocity of center of mass is 0, so center of mass will not move at all. If it is here initially, it will remain here always. Now this block will go forward, come this side, go forward, come this side. So this becomes mean position. So the center of mass becomes mean position of SHM. Now this block and this block is doing SHM about this mean position. Now I can apply the center of mass idea, that is if this is origin, if I can do calculation and I can find what is the relationship between the distance of these two blocks with respect to center of mass. So how far away? So one block is how far away from the center of mass. I can find m1 plus m2, m1 x1 plus m2 x2 is equals to 0. From there I can find x1 by x2. And then I also find what is the relationship between velocity, and I can also find what is the relationship between kinetic energy, that is k1 by k2. And I have taken a special case when m2 is greater than m1, that is the higher mass m2. So this means in that case this one lower mass will go more away from the mean position. The heavier mass will go slow, and that is obvious. If something is heavy, it will go very less distance from the mean position. That is a lighter one will go more distance away from the center of mass. That is happening here. This is going more away from the center of mass. This is going less away from the center of mass. Are you getting or not? Now, similarly, I can find velocity. So v1 is greater. So the lighter mass has a higher velocity. Now, if you see kinetic energy, once again, the lighter has also higher kinetic energy. Why this is happening? Because you see, kinetic energy is proportional to v1 square and m1. If the mass is increased, this is only increased one times. But if you increase velocity, it will be a squared. And that's why velocity will dominate. In the kinetic energy, you see velocity is a square. If the masses are doubled and velocity are doubled, then velocity will dominate. So v1 square, and that's why kinetic energy, in the term of kinetic energy, one has a even lower mass but higher velocity. It will have a higher kinetic energy. This is because the velocity is squared there. We'll discuss the next problem. That is a quite interesting problem. So let us copy this one. I think all of you have copied this one.